So let's look at how we're going to make some alkynes. We're going to make them by treating an alkane dihalide with 3 equivalents of a very strong base, sodium amide. Sodium amide is not dissolved in water, but it's dissolved in liquid ammonia. The treatment is followed by a treatment with water to reprotonate. Okay, so let's look at what the reaction is going to look like. This base here, let me get a different color. This base here is going to come in and take one of these protons. The electrons that join that proton to the carbon are going to now go between the 2 carbons, and we're going to kick off one of our losing group. We're going to lose one of our bromines. So then we're left with this structure, and again, the base comes in, it takes a proton, the electrons joining the carbon to the proton now go between the 2 carbons, and our bromine is our leaving group, and we're left with this structure here. This is the way you'll see it written. You'll start with your dialkyl halide, 1 excess sodium amide in liquid nitrogen, followed by treatment with water, and that will give you your alkyne. We can have 2 different kinds of dihalides. We can have a geminal with both halogens on the same carbon. So we'd have this example. You have a bromine, something else, and another bromine. But anyway, they're both on that same carbon. Or they can be visceral, and that means they're next to each other. So the halogens are on adjacent carbons. And for that, we'd have a structure like this. And here's one of the bromines, and the other bromine is down here. So this one is on this carbon, and the other bromine is on the other carbon, but they're right next to each other. So let's predict the major product and draw the mechanism for these 2 problems. It'd be a good time to stop the video and attempt this on your own, and then see how you do. Okay, so we start with this compound. We're going to first treat this with our amide, 2, in ammonia. Our amide here is going to act like a base, and it's going to pull off a proton. So we need to find a proton. We don't have any protons at this position. We just have R groups. The only protons we're going to have are here and here. So our amide comes, it pulls off that proton, and the electrons that are attaching it to the nearby carbon will make a double bond here, and we will kick off one of our bromines. So we'll end up with this structure. Okay, while I have the camera off, I did add a proton here. This was originally a methyl group, and so it would have had 3 protons around it. We removed one of them in the first step, and so now we're left with 2. Again, we have an excess of this amide, so it's going to come in, it's going to steal another proton. The electrons that are attaching the proton to the carbon will then make a triple bond, and we'll lose our bromine. And then we'll end up with this structure. So we've removed the other proton, we end up with this structure. Remember, we have an excess of this amide, so it's going to steal the last proton, and then the electrons that are joining the proton to the carbon will go and live on the carbon, and we'll get the structure. With a negative charge here. Our next step will be to add water. And this negative charge will then be able to steal a proton from water. And we'll end up with our final structure has this kind of end to it, and then triple bonds with a hydrogen on the end. Remember, there's a carbon here and a carbon here. Okay, so let's look at the next one. So here's our amide. It's going to want to pull off protons, so we have to figure out where the protons are. Here we have two chlorines that are vicinal next to each other. So there's a proton here, and we'll find a proton here. Actually, two protons. And so this will first pull off this proton, and the electrons will go to make a double bond. And our chlorine will be a leaving group and will leave. That leaves us with the next structure that I've drawn. And we'll have another amide come in. And it will grab another proton. The electrons joining it to carbon will make a triple bond, and we'll end up with this structure after this chlorine is removed. Okay, so they have a leaving group. So we end up with this structure over here. There's more sodium amide hanging out, and so once again, the proton is snatched, and this negative bond ends up on the carbon that has the triple bond. There's a carbon here, and it's got a negative charge. When we treat with water, we rehydrate that position.